Hello, relativity friends. I recently did a video on comparing what I called a pure math book to an applied math book. I'll leave a link in the description. And several nice commenters have said the book that I was calling Differential Geometry is actually a book on topology. And the more I dug into this, the more I understood what they're saying. So I was comparing apples to oranges, basically. So let's look at those two books real quick. So I was comparing this book, An Introduction to Manifolds by Loring 2. I was comparing this to the next book I'm going to show you, and I was calling this Differential Geometry. And I was comparing it to this book, Riemannian Geometry, A Beginner's Guide by Frank Morgan, which is actually differential geometry. So that led me to, because I don't know what topology is, it led me naturally to the question, what's the difference between differential geometry and topology? Okay, so thanks to those commenters, I set out to try to understand what is the difference between differential geometry and topology. Okay, and there's a lot of information out there. I watched YouTube videos, I did some text reading, I even asked AI, and I boiled it all down to something I can understand because there's a lot of words. What's topology? Topology studies the properties of spaces that are preserved under continuous deformations, stretching, bending, twisting, but without tearing or gluing. These are called topological invariants. Here's something key to me. What does it ignore? Precise measurements like distance, angles, curvatures, and volumes. What is this? Well, that's the metric tensor, which is fundamental to Riemannian geometry. So, wow, no wonder I had them confused. What's differential geometry? Differential geometry studies the smooth manifold, spaces that locally resemble Euclidean space and have a notion of differentiability. So in my P brain, this is global. So they're looking at the whole space, not really caring about the way we do in this, where we zoom in, keep zooming in until we get a locally Euclidean space that we can work with differentials in, right? So we have tangent spaces on manifolds. So that is huge. That's a huge difference. Here is the best analogy I found. I love this one. Think of a piece of paper. Topology would care if the paper had holes, such that a single sheet versus a hole punch, as an example, rather, a single sheet versus a hole punch, it wouldn't care if you crumble it, stretch it, or roll it into a cylinder, as long as you don't tear it or glue edges together. Differential geometry would care about the curvature of the paper. Is it flat? Is it bent? Like part of a sphere or a saddle, the distance between 2 points on the paper, or the angle between 2 lines drawn on it, which is, once again, the metric, right? So, gosh, you know what? There's a huge amount of difference between differential geometry and topology. This is what I'm interested in. This is because I'm interested in general relativity. So this is what I'm interested in. Topology, I don't know if I'm interested in it or not. Someday, if I live long enough. Anyway, I'll see you later.